Hello guys, today I'm talking to you about an exciting topic. This is called electric charges. Okay, so in this demonstration right here, think of these orange circles here as the nucleus of an atom, and think of the blue ones as electrons, okay? Say, for example, you have a battery. Let's say this in red. Say you have a battery on this side, and then you have, say, a light bulb in the center, like right here, and let's say this is the wire right along this path. Once the wire flows through here, turns on the other light bulb, and returns back home, right? It goes this way. So imagine this was how a circuit worked. These were all nucleuses of the thing, which is just the material basically. Think of it as a material, either a conductor, which would be, say, copper. So each one of this would be, say, a nucleus inside it, but don't get too involved in it. The idea I'm trying to tell you is just electricity. So let's say this battery was on. Say it was on. The current would flow from here first. What I mean by current, first of all, let's back it up. These blue particles, if they were to move along this line right here, you see how they're in the middle, then there are these rows and columns here? Yeah, each inside each box is the nucleus, and around the nucleus are, say, a couple of electrons. Now these electrons may wander from, say, from this spot, it may go this way, and it may transfer to, say, like right here. So it may wander, but it's always in this, like, some sort of grid, and this grid determines the spot where it wants to go. So if this electron wants to go, say, here, then it can go all the way down and right, and then it'll reach that spot. So it honestly depends on factors such as that. That's how electricity moves. It moves in this white line like grid. So what happens is, if the current is generated, the electricity is going to move along this path, as we know, because this is the negative terminal of the battery, and this would probably be the positive, or not probably, but it would be the positive. And so it moves this way, and all of the electrons are going to be flowing through this. And because they're flowing through this, they're flowing on the line here, on this white line here. And they're going to be moving all the way through here, around everything. It's going to power on the light bulb because electrons are actually flowing into it, going all the way around, and theoretically, let's just add another line. It would flow through here, and then it would flow all the way back, go through the other light bulb, and then come back into a complete loop with the battery. This is exactly how it's supposed to look in the atomic level. The atomic level is extremely small, but there are parts that are a little bit smaller than that. This just shows you an active demonstration of how the charges are moved in current. So the current this way is going towards the battery, is going this way in a circle, but it can move the other way. Say, for example, if this was positive and this was negative, and the light bulbs may not even be there. It would just be a resistor there. So what I'm just trying to say is these grid-like formations is it's a key thing to understand, especially in the realm of physics and engineering. So the nucleus, think of the nucleus as this big compartment. It's like a car garage, basically. And when you have the car garage, you're going to have things that are outside of it. Say the wrench and stuff. The wrench, well, maybe another car garage wants to borrow it. So it moves, and it moves in these, like, lines, right? So if they want to borrow a wheel, the wheel's just going to move there, and, it moves in the lines. It's going to always rotate around. It's always going to be on the premises of the car garage, but it can move. So that's basically what electricity is. The flow of electrons, the flow of these blue dots, is what electrons are. That's what electricity is. And a current is just how fast it moves, basically. Anyway, that's it for us. Thank you.